All right, so this lab is for vectors. So if you go to the lab menu and we see, so basically use this simulation. So when I talk about this GAD, so I'll just turn off my camera. Okay. Let's see. Okay, so we use this link to do the simulation. So basically in vector, I'm not sure how many of you have learned vector in the lecture. A vector is very different from like what we said, like a distance or any object that only has a magnitude. So for a vector, there are two quantities that really need to consider. One is the scalar, one is the magnitude, one is the direction. So basically when we see a vector, for example, this vector, so it directs the direction, also has a magnitude. Magnitude is the absolute value of this. Let's say this is 3 kilometers long, and so let's say, okay, 3 centimeters long, and the direction is pointing to this way, and you just, so you have a tail and a head. So basically you have this, so this indicates when you have a vector, you basically know the absolute value, which is the absolute value of this length, which is known as magnitude, and also the direction. You will know the direction as well. So how do we normally calculate? So we can dissect the vector to be the horizontal one and the vertical one. So for example, this one, so because it's not like a very horizontal or 100% vertical, so we can dissect like a to make this arrow project on the, let's assume this is x axis and this is y axis. Let me see if I can draw something. So let's say this is x axis. This is y axis. So we can do a projection that, so this is, let's say, this is A. So this is will be AX. And this one project on the Y along the Y axis. This one will be the AY, which is the vertical part of X. So, so when we calculate the magnitude of AX, we use a sine theta. This angle is theta. And when we calculate the vertical component of vector of AY, then we use A times cosine theta. Okay. Erase all of them. So basically, this is what we just draw earlier. This is AX, A cosine theta, and AY, A sine theta. So basically for a vector, it always, when you add two vectors together, it always had to tail. So it will connect all the vectors together. So for example, I think I can, let me see. I can start a show you example. For example, explore 1D. So let's say if I have a vector like this, and then I have another vector, but if I want to add these two vectors together, so basically I put the head to tail or tail to head. So at this, so excuse me. So if you see on the red button here, it has a sum. So sum is basically it measures the sum of these two vectors. One is, let's say this is 1 is 5, one is A is 5, B is 5, but they are both horizontal, right? And then, okay, so this is better. So when we add them together, we normally put them head to tail. So this connect together, then you can say there's 10. It's just a like example. And mathematically, when we try to calculate the magnitude of a vector, so we use absolute value r. So this is basically the x square, y square, and take a square root. Then you get the r absolute value of r. So when you try to calculate the angles, then so if let's say I want to calculate the angle here, you use tangent, which is y over x. So this is tangent theta, and then you can look up on like online to figure out the angle. So then we say, let's say this is like you have the x and the y that they're asking you to calculate the resultant. So when the x and the y axis add up together, you see it calls it resultant. So the resultant, when you indicate the resultant, you have to specify what is the magnitude and the direction. So you always remember the vector has two factors you have to consider. One is the magnitude, one is a vector. So okay, so the first part is try to explore. You just like try to click, and then you can make it longer, and just play around. But basically, you don't have any work that need to be done in the part A. Just play around. Let me see what else I left here. So any questions so far?
Nope.
All good.
Thanks. So the second part is, I guess it's still you're exploring for two-dimensional vectors. So let's say, let's go back. Okay, here, explore 2D. 2D, that means, so 1D, we only have one dimension. So that means only have x-axis. 2D, we have like x, y. So basically when I put like a drag A, vector A and vector B. It's still, and you can click the sum, that means the sum total, and the value that indicate the value of both of them. And you can move them a little bit away from each other, so you can clearly see the value, and also the angle, you can click the angle. So basically how it works is, so this one, the darker blue, is the sum of these two small vectors. And you see here components. Components, that means they dissect the vector to the x and y axis. So let's say, let's use this one. So like basically they are, when you add them together, or just try to. So this add up together, you can see, okay, I think I can. So when you put these two small vectors here, you can see even these two vectors are not lined up, and as long as you keep their head to tail, and they will the sum of these two vectors will always be the straight line from the tail to the head. So it always, let's say if I change a little bit the angle, can I change the angle? I guess I cannot change. But yeah, basically what I mean here is as long as you keep the head to the tail, and they you can like measure everything. Okay, let's put another one here. So put it here. So you see, this is always a circle. So the sum will be the shortest from the more direct way from the tail to the head. So it's just like the A vector, B vector, and C vector. Even it draws a big circle, but the sum of these three vectors will be from the tail of A vector to the head of C vector. Okay, so so it's still like asking you to try practice, just play around how to use the vector and how to, you see, when I try to draw a vector, I just draw from here, draw from this box, and I could hide all this that I could hide this x and y axis dissected values components, x, y components, or I can choose a different way to represent them. So that's basically how you play with the online simulation. So this is the lab. So what we're gonna do here is, so basically before we go into the lab, we have to compare two concepts that's maybe very, very confusing. One is resultant, one is equilibrant. Resultant, as I already mentioned, so when the two vectors add up together, the sum will be called resultant. And the equilibrant will be will share the same magnitude, but the totally opposite direction. So you see here, we have two vectors. One is horizontal 19 Newton and one is vertical 12 Newton. The sum resultant will be from the tail to the head. And the equilibrium, if you parallel move this resultant to here, and the equilibrant will be the same, will have the same magnitude and the opposite direction, which is pointing to this way. In this practice, you will draw two vectors, and when in the vector v1, v2, and you calculate, you have a calculated r, and you observed r, and also record it, and you try to write down the equilibrant. So how we're gonna do that? So basically, let me see. So basically, let's say we have two vectors, like put one here. So this is, we can call this V1. V1 has to be 5 units to 10 units. And the theta, okay, because we don't know and we have to put a value so we know how big it is. So we can, you can put your mouse here and then try to drag it, pull it longer or pull it shorter. And then you see, here's the unit, and then the theta will be the direction. You have to put the theta here. Theta will be from 10 to 17. And so we can call this one is V1, and we can still call, we get another vector called V2. So V2 has to be from 10 to 20, and then the angles will be 100 to 22. So you just randomly pick up your two vectors as long as they're qualified for the requirements here. And then, so this is the two vectors you draw. And then you calculate, so you can record, the first one record the angle. You can just read from the graph, the angle V1x, V1y. So when you click here, I say, at first maybe you don't have this, and you click this one and it shows like V1x, V1y, and this is V2x, V2y. So you record the data here. So basically you don't, this doesn't need any brain work. You just record the data. And then you have a calculated resultant and observed resultant. Calculated resultant is how you calculate them by, so when you add them together, let's see, and you can pick another one. Sorry, pick another one. So when you calculate it, this is the vector 1, vector 2, and you wanna, from the tail to the other, to the head. So this is totally, this is basically, so you use another one to measure, and this is X, this is Y. Since you know the Rx and Ry, so you will do the square root. Remember, we have an equation here. So let's say we know this one, X is -1 squared plus 15. So this is 15 squared, and do the square root. So will be, the resultant will be 15. So resultant will be 15, and then you can calculate the angle by Vy over Vx, which is 15 over -1. So you can look up and say tangent, arc tangent -15, and what's the angle? And you write down here. This is how you do the calculation. And so this may be a little bit like this is just like need a little bit of math, and so you can move here. And another one is you try to observe. Observe is you click sum. You click sum, then I don't think I can see. Okay, you click sum. So this is exactly like what we measured here, right? So the sum will give you the result. What is Vx, which is Rx and Ry, and the and R magnitude will be 15. You see, here is the magnitude as sum, and then the angle. You can click the angle as well. I think this one, the angle. Okay, the angle here is 93.8. And you can compare the value between the resultant value between what you calculated and the one you observed. And then in the end, you write down the equilibrium. And we know the equilibrium is exactly like the resultant. So their magnitude will be the same. Angle will be 180 degrees difference. You can, let's say this one is 93.8. You can minus 180 or you plus 180, which is the angle, which here, the angle will be 93.8 minus 180, and you get the number here. Or you can 93.8 plus 180 and put the number here. And then the X and Y, because they're totally opposite, let's say, okay, I can get another one. So let's say this one represents the equilibrium. So this will be, okay, so this will be the equilibrium of the sum of the resultant. So you can say the X will be minus resultant X, Rx, and the Y will be minus the resultant Ry. So this is the tricky part. You just have to, when you get confused, you can draw from the board and see how the equilibrium different from the resultant. Does it make sense?
Yeah, makes sense.
So you can compare the difference, and so maybe you get a very different value from what you calculated and what you observed. Then you can possibly write down why you have this like a difference. As we already mentioned in the first class, so when we do measurements, it really depends on the person, and there's some errors we cannot avoid. So maybe it applies here when you try to do the math, or you try to do like the square root of a number. Maybe you didn't get exactly the same one as they calculated from the sum value of two vectors. So it just like it's totally fine. So you just compare and see what could be the error or what contribute to the difference. And then another one, the last part is, let me see what time is it. Okay, let's see, got the time. So the last part is how to apply these vectors in our real life. Because when we are driving, let's say we are driving on the street, we always know like, oh, we are heading to north, and we have like a driving speed or something, like we basically give the magnitude. Like it really depends, like if we drive for 1 hour and maybe how long, then we know how long the distance we have to drive, and also we have to know the directions so we wouldn't get lost. So in the real life, let's say a pilot. So when we are taking flight, the pilots always end up in the same airport, is because they have the navigators to direct them. So here is the example. It says a pilot flying her Cessna aircraft at the speed of this, due north from Long Island to this Sky Memorial Airport, Connecticut. There is a strong 80 kilometers wind blowing from west-east. Okay, so I think here, so since we already know, then I just clear everything. So when I do any physics question or math questions, I like to draw what I learned, what I read from what information I get from the question. So let's say, okay, so let's say this is the board of the pilot. So we have so we're hiding, so imagine we're her. So we're going, okay, I just want to clean. Yeah. Okay. So we have, let's say 21, maybe you can use 21. Okay, so if 1 unit represents 1 kilometer per hour, so we have 21 as the speed. So at the speed of 210 kilometer per hour due north. So this is aircraft due north. And then there's a strong wind. There's strong wind from blowing from west to east. So from west to east. So how big is it? It's 80. 80 then. Okay, this is 80. So basically the aircraft is flying this way, and then there is a strong wind blowing from west to east. So this is, so the sum will be how the aircraft end up being flying, which direction. So basically it is not flying to the north. It has a slightly change its direction. So make sure a scale of 10 units on your grade to 100 kilometers, which we already did. And draw vectors to represent her aircraft and crosswind. So aircraft and crosswind. Determine the resultant direction and speed of an aircraft. Okay, so we can say when we try to determine the direction and the speed, and then we can use this one to show. So the sum will show like the, okay, let me see, the angles too, right? If you feel it's very confusing, you can just move a little bit. So you know the speed is 22.5 with the angle, how do you say? 69.1 degrees due north, right? So if there's still angle, give the direction theta, which should point her aircraft nose in order to remain on course to her destination. So we don't have to worry about their navigation system. So here we don't worry about anything about the navigation system. We just read all the information from here. And so basically, if they ask you if they want to remand the sum to be on due or north. So basically, you have to adjust the directions. Let's see if I really want to make the sum to be north, so I have to adjust this one. Oh, sorry. You see the sum? Okay, I guess I have to move it this way. Okay, just try to make it, okay, this is 19. I still have to do a little bit more. Okay. I think I cannot write. I guess it cannot do, the maximum you can do is 21. It's still remain north, right? So they are asking you what she should do to remain her like overall direction due north. So this is what she has to do, because the wind, you cannot control the wind, and the only thing she can do is try to due west a little bit. So then she can make the sum end up being in north. So this is what you do and what you will draw, and then you take a screenshot, show me how she's gonna do to make her flight remains on her destination, remains on course to her destination. So then you record the screenshot. And then the last one is, in order to land, and she has to slow down her speed. So when her slow down, that means so this is the absolute value is decreasing, right? The magnitude is decreasing. But she has to remain to make sure the sum will be on the north. So what she has to do? She has to make her directions even more towards west. That's what she has to do when she decrease her speed. So how will this affect her ability to stay on course from a north aligned runway? So if she doesn't change her direction, as I said before, this is still the same direction and the speed she's flying, and then if she's decreasing her speed without changing her direction, so what will happen is she will not be able to remain on the north aligned runway. And the correction she could do is to adjust the direction more towards west to make sure the sum will still always remain on the course. Correction action. So she has to adjust her flight more west, more towards more west, to remain on the course. Any question?
I have a question. So I just want to confirm. So on this last part, since we can't get the snap points on the grid to be exactly 21 for 210 kilometers per hour, you want us to use 21.5? Or should we actually do the math and figure out what it should be exactly for 210?
Right. I think you should do the math.
Okay.
So the grid, just like when you take the screenshot, just tell me how you understand, so you understand it correctly, and then you do the math yourself.
Okay. All right. Thank you.
Yeah. Yeah, that will be all for the lab. Any questions? You learn vectors from class?
Yeah.
Okay.
Yep.
Any questions? So basically, if you have any question or you have any homework question, you can ask again, send me your questions before so I can look it up so give you a better answers, or we can discuss in the class. No more questions? So if you have any question or you have any concerns, I think the lab is pretty straightforward, and you can check. I will upload the recording later, and then you can check the recordings and see if you can understand. But if you still cannot understand or you're missing any information, you can write email to me. But I highly recommend to watch the YouTube. So I'll post on YouTube. You can watch that and try to find your find the answer to your questions.
So this lab will be due next Tuesday at 11:59 p.m.?
Yes.
Okay, cool.
So yeah, just try to finish your last lab report. So I guess tonight or not tonight, maybe tomorrow I can start grading your lab report. The summer is pretty fast. It's like a go, go, go.
Yeah, that's true.
Yeah.
Do we get our grades back for the labs on Blackboard?
Yeah, I'll upload your grade on the Blackboard.
Thank you.
Just to confirm, do we submit the lab as a PDF or a Word document?
I think you can submit it as PDF. So when I open them, I can directly see your report. But Word is also fine.
Okay, so thank you.
Allergic, yeah. Okay, any other questions? So let's see how many seconds. Okay, we still only have five students. Thanks everyone who has submitted. But so yeah, everybody please submit their lab report by tonight, so we don't delay to upload your grade. And so that'll be all for today.
Thank you.
Well, thank you very much.
Okay.
See you next Tuesday.
Thank you.
Thanks. Bye.
Have a good day.
Thanks. Oh my God, I forgot to take attendance. So everybody already left. Okay. I guess Zoom maybe can record who has attended. Okay. So with all of them, all of you who stay here, let's start recording. Let's see. So before you leave, we take attendance, and then I try to figure it out. Okay, so maybe I can check the Zoom, so everybody can leave now, I guess. Okay, thank you, everyone.
Thank you, Professor.